Hello. In the course of this video, I will demonstrate using Wolfram Mathematica 9 how to find the indefinite integral of a vector field in 3 dimensions. Alright, first, my goal is to find a function e such that the gradient of e equals, let's see if I can't get equals the partial v with respect to x, and the partial v with respect to y, and the partial v with respect to z equal to the component f1, the component f2, and the component f3 of the vector f. Alright. So, first what I need to do is define the components of f as the partial derivatives of some function e. So that means that e, the partial v with respect to x, equals the first component of f, 2x to the power of 2 minus 2y to the power of 2 plus 2z to the power of 2 plus 2x times y plus 3y times z plus 4x times z. And that means the partial of e with respect to y equals the second component of f, x to the power of 2 plus y to the power of 2 plus z to the power of 2 minus 4x times y plus 2y times z plus 3x times z. Ooh, I've made a mess here. You should look at the screen while I type. X squared plus y squared plus z squared. There we go, much better. Minus 4x times y plus 2y times z plus 3x times z. And the partial of e with respect to z equals the third component of f, 2x to the power of 2 plus y to the power of 2 plus 3z to the power of 2 plus 3x times y plus 2y times z plus 4x times z. And let me make sure I typed all those out correctly. 2x squared minus 2y squared plus 2z squared plus 2xy plus 3yz plus 4xz. X squared plus y squared plus z squared minus 4xy plus 2yz plus 3xz. 2x squared plus y squared plus 3z squared plus 3xy plus 2yz plus 4xz. Alright. And I will evaluate all these. Now, I need to integrate each partial derivative with respect to its, I need to partially integrate each partial derivative with respect to its corresponding variable. To find possible, let's leave it at that. Okay. So what I need to do here is a possible e is the integral of e sub x with respect to x plus a constant of integration that depends on y and z. And Wolfram is still remembering what I had my constant of integration defined as in a previous notebook file. So And for some reason, it also won't let me clear it. Alright, let's try this. Clear C, Y, Z. Nope. Alright. How about C, Y, Z equals C, Y, Z? Nope. Yes, that is true. Good job. Well, for the life of me, I cannot clear this variable. So I'll use a different one. I'm going to say lowercase c. That's my constant of integration. Okay, now to explain the constant of integration. Normally, when you're integrating, you can have a constant of integration, but because I'm partially integrating a partial derivative, my constant of integration can still depend on terms that were held constant during the partial derivative. So, because I differentiated with respect to x, any y and z terms would have been held constant. Therefore, my constant of integration can depend on y and z. And to get rid of this factor here, I'm going to expand this. Nice. Now, another possibility for e is the integral of e sub y with respect to y plus a constant of integration that depends on x and z. And the third possibility equals the integral of e sub z with respect to z plus a constant of integration that depends on x and y. Right? These are my possibilities for e. Now I need to identify these constants of integration. So, identify the constants of integration. So, I need to find this constant of integration, I need to find terms in the other two possibilities of e that depend only on y and z or both, or y or z or both. That way, this constant of integration can make up for the terms that E1 lacks that are found in E2 and E3, and I need to do this for all three of them until all three functions are the same, and that would be my E. So, C sub yz equals. Now I'm looking for terms in E2 and E3 that depend on y or z or both. This depends on x, that's out. This depends on x, that's out. Looks like I have a y cubed over 3. This depends on x plus a y squared z plus a yz squared. And I'm going to put a multiplication sign in there so that Wolfram doesn't think yz is a single variable. Alright, that seems to be all in E2. Let's look in E3. This depends on x, this depends on x. I already have a y squared z. This depends on x, I already have a yz squared. Looks like I get to add a z cubed. Right? Now I want to find the constant of integration that depends on x and z. So now I'm looking for terms in E1 and E3 that depend on x or z or both. So it looks like I get a 2x cubed over 3. This depends on y, this depends on y, plus a 2x squared z. This depends on y, plus a 2xz squared. Again, adding the multiplication sign. Now I'm looking for terms in E3. I already have a 2x squared z. This depends on y, this depends on y. I already have a 2xz squared. This depends on y. Looks like I get to add a z cubed. Finally, I'm looking for the constant of integration that depends on x and y. So I'm looking for terms in E1 and E2 that depend only on x, y, or both. So it looks like I get to add this 2x cubed over 3 again. This depends on... Oh, that doesn't depend on z. I get to add this. And this also does not depend on z. I'm going to start the multiplication sign. This depends on z, this depends on z, and this depends on z. Okay, now I'm looking at E2. I already have an x squared y, I already have a negative 2xy squared. I get to add a y cubed over 3. And then this depends on z, this depends on z, and this depends on z. Okay, these are my constants of integration. Now, huzzah! Now that I've defined my constants of integration, these functions are now all completely equivalent. Alright, now my function e is simply any one of the possibilities of e, so I'm going to just use e sub 1 and evaluate. And this is my function e. Now, I need to round out the problem by evaluating the problem specified here. So, e sub 1 evaluated at x is 1, y is 1, z is 1, minus e sub 1 evaluated at x is 0, y is 0, z is 0. And that is the answer.